In this video, we're going to tackle task 19. Task 19 is about plotting the cost effectiveness acceptability curves, the CACs, the cost effectiveness acceptability frontier, the CAF, and also the expected value of perfect information, the EVPI. So on the right, I have the probabilistic result sheet. I'm going to come down. There's some new rows that have appeared, and these figures will appear for us once we complete the data table at the bottom, the chart data table. Okay, so step 19.1. A new table is visible at the bottom of the probabilistic result sheets in rows 112 to 113. The first task is to complete these cells in row 113. Okay, so we need to pull in the value of the CAC given the current settings of the model. Right, so the current cost effectiveness threshold in particular. What is the value of the CAC? What is that percentage for treatment A? What about treatment B? What about the CAF? What about the EVPI? And so if we go back to, I believe it's the incremental net monetary benefit sheet, you can see these just here. So these are the values we want, and then finally the EVPI just there. Okay, so we're going to put in, and these have all had names assigned to them. So our CAC A, that's the first one. Our CAC B is the next one. Our CAF is the third one. Then our EVPI, that's the fourth one. Okay, so this is a little bit like the simulation sheet. If you recall, on the simulation sheet, we were pulling in values from the model sheet and putting them all in one row. And so we could then copy them down for each of those iterations of the model. Now, what we're doing here is we've got all this important information given the current settings of the model in one row, and then we're going to change not the iteration number, but the cost effectiveness threshold. We're going to try different values of the cost effectiveness threshold, and for each one, we're going to take this information and we're going to copy it down. So again, in practice, we would use a macro for this. If you were doing this in Microsoft Excel, I would recommend using a macro. You can do far more threshold values than we are doing here. We're going to just do a few threshold values. We're going to do it manually just to illustrate the principle of it. Okay, so in step 19.2, add the $0 per query row to the data table. So we need to go to the setting sheet. We need to change our threshold to $0 per query. So an extremely low. I mean, this is unrealistically low. Of course, we don't value queries at 0, right? That would imply that we don't value health at all. And then our economic evaluation effectively collapses into a cost minimization analysis if we don't care about health. But nevertheless, it's common to plot the CACs and the EVPI across a range of thresholds starting at 0, even if that's not particularly realistic. Let's go back to the instruction sheet. We've changed the threshold. Understandably, the probability that treatment A is now cost effective is exactly 100%. Previously, there were some iterations where B was cost effective. Well, that's not the case. If we value health at 0, given that treatment A is just unambiguously cheaper than B, well, this is now 100% A, 0% B, and there is 0 EVPI. So we're going to take those cells, we're going to copy them, and what we're going to do is just paste the values into this range here. Okay, and those are correct. And that step is now complete. And what's happened here is the sheet has expanded, and you'll see that I've already provided for you the results that you would get if you did a threshold of 10,000, 20,000, 30,000, 40,000, 50,000. So all the way up to 90,000. These have been provided for you. And you can see that starting at around 50,000, we're beginning to get a little bit of uncertainty creeping into this. There's a possibility at $50,000 per query that treatment B is cost effective. And as we increase the threshold above that, there's a growing probability that treatment B is cost effective, which in turn gives us a higher EVPI. Now, we're going to do the 100,000 row now. So let's go to the settings, change this to 100,000. Okay, so we've updated this to 100,000. That's caused this current value range to update. So I've selected that. I'm going to copy it and I'm going to paste as values. Really important to paste it as values. You don't want to have formula, even if the formula is copied correctly, you don't want to have formula down here, because that would mean when you update the threshold the next time, these cells are going to update. We don't want that. We want these to be static values. Okay, so now the sheet's open up a bit further. You can see we have the values for 110,000, 120, all the way up to 190,000. And I did these using a macro. So the way in which I generated these values was to take this sheet offline, write a macro in Excel. That's how I did this. And this is what you would do if you were building a model in production to submit to an HTA agency, for example. You would build it in Excel and you would run macros. Ideally, you would actually build it in R, but that's another debate. But yes, you would use a macro, and you can do a macro in Google Sheets, but the way in which they work is slightly different from Excel. Because they're in the cloud, there is that latency between running that macro and writing it to the sheet. And so you will find it quicker to do it in Excel on a production model. Okay, the next instruction is to add the $200,000 per query row. So we're going to go back to the settings, change this to 200,000. Wait for the sheet to recalculate, and you'll see that these numbers now have recalculated. So I'm going to copy them, and I'm going to paste them down here, just as values. And you can see a nice pattern going on here. By the time we're willing to pay 200,000 for a query, the probability that A is cost effective has fallen down to about 10%. The probability that B is cost effective has gone up to about 90%. You'll also see that the EVPI is falling at these very high thresholds. The reason it's falling is because all of the interest was around about $100,000 per query, given that the ISA is approximately $100,000 per query. As we raise the threshold above that, the uncertainty becomes less. It becomes more and more certain that actually B is cost effective. And that causes the EVPI to fall, at least temporarily. So if we were to increase the threshold even higher, any uncertainty that B is cost effective would then have a higher consequence. So it is possible for this curve, if we just go up, look at the EVPI, it is possible for this to then start rising again at higher threshold values. But typically we see these peaks close to the ISA for the technology. Okay, instructions, return the threshold to its default value. So we'll go back to settings, change this to 50,000. And while it's thinking, if I just go up on the right, you can see we have, it's replotting the probability map. You can see the CIAC curves here, right? And the gray line is the CIAF, that's plotting the CIAC for the treatment that is cost effective at that particular threshold value. Okay, so as you increase the threshold, the probability that treatment A is cost effective falls, and the probability that treatment B is cost effective increases. Okay, and this brings us to task 20, the final task, which is the price reduction analysis for treatment B, and we will consider that in the next video, and I'll see you there.